there, kids. How are you? Nice to see you. Thanks for coming to the party. All right, here we go. Wow, that's really weird how this didn't print out right. I hope. That's weird. So Mr. Key doesn't really have a place for his name, so he's going to put it over here in the holy mackerel, my pen's getting worse and worse day. All right, so what are we doing here? State your answers in interval notation. So the first thing we got to do is factors. Oh, look at me giving you hard factoring. 3x squared minus 5x minus 20 greater than or equal to 0. Now, don't forget, greater than or equal to 0 really means positive. Now, as far as a graph, that means, for what that means as a graph, it means above x axis. I cannot wait to get a pen that works nicely. So we're going to factor this. Let's see if I can do this nicely. See, every time, I'm not even touching the thing, and it's just making pen marks. That's why every time I pick the pen up, I got to like pick it up and put it down. All right, so 3x squared, or 3x and x, it's going to be 5 and 4. What do you think? 5 and 4? How about 4 and 5? This would make minus 8, and this would make plus 5. No, that's not going to do it. Not going to do it. Let's turn it around. How about go the other way? How about we put a 5 here and a 4 here? That's not going to do it either. Let's delete. 5 and 4 don't appear to be working very well. 15, 12, and 5. Oh, that's right. I changed this to a 7 in class. I put it out of my remind that this is a 7. So yes, I was right. I believe that this is, totally forgot what I'm doing here. Oh yeah, 4 here and 5 here. So that's negative 12 and positive 5, that makes 7. Okay, so my two answers are x equals negative 5 over 3 and x equals positive 4. Okay, so I come over to my number line, and negative 5 over 3 is somewhere around over here. And 4 is over here. So again, think about this way. If you graph this puppy on a pair of coordinate axes, and you have a little negative 5 over 3 here and 4 over here, it would look something like this. Actually be a lot steeper, a lot narrower because of this 3 out front, but because it's positive, it's going up. Now, I want where it is greater than a 0, and again, that's where it is above the x-axis. Now, it can be equal to, so we're going to use solid dots. So I know at these 2 points, we're going to use solid dots. And since it can be in this general area and this general area, I want to just go out going this way. So in interval notation, that would be negative infinity to negative 5 over 3, bracket, union, bracket, 4 to positive infinity. All right, problem 1's done. A plus BI form means we're going to have a negative under the radical. So I'm not going to divide by negative 3. That would be stupid. So clearly I'm not going to do this by completing the square. That would be dumb. El stupido. So we're going to do it by quadratic formula. A equals negative 3. B equals 8. And C equals negative 6. Upstairs. Go. Upstairs. Call him. Oh, I was live. Oh well, my dog was annoying me. So, anyway, so live, here we go. D equals, I don't need this up anymore. B squared minus 4AC. Am I still recording? See, my computer's down crazy on me. B squared. B squared is 8 squared, which is 64, minus 4 times negative 3 times negative 6. Ooh, man, that's a lot of craziness. So that's 12 times 6. Three negatives make up negative. So this becomes 64 minus 72, which is negative 8. All right, so now we're going to do the quadratic formula. Let me get rid of this thing. I don't need it anymore. So we're going to do x equals negative b, so negative 8, over 2 times a, negative 3, plus or minus the square root of negative 8 over 2 times negative 3. Now, if I remember correctly, I do. This is really equal to negative 4 times 2, and the square root of negative 4 is 2i. So this becomes 2i square roots of 2. These 2's cancel. This 2 goes in here 4 times. So what I end up with is x equals negative, well, that's a negative over a negative, so that's just positive 4 over 3 plus or minus negative I square roots of 2 over 3. Now notice I just brought this negative up to the top. That's okay. I just like that better. That's okay. There it is. All said and done. Cube roots. So your cube roots are 1, 8, 27, 64, 125. And I believe the one that actually goes into 192 is 64. So we're going to do negative 64 times 3. And now we're looking for groups of 3 because this is a cube root, sorry. So we're going to do x. Ooh, what the heck? There's no x in this thing. I saw. So we're going to do a to the 6 times a. B cubed is already a multiple of 3. C to the 9 times c squared. We're just looking for multiples of 3. D cubed times d. So there's 4 d's, there's 11 c's, 3 b's, and 7 a's. So we'll go through with our pen. Cube root of negative 64 is negative 4. The cube root of a to the 6 is a squared. The cube root of b cubed is b. The cube root of c to the 9th is c cubed. The cube root of d to the cubed is d. Cube roots, forget this cube root, you lose a point. It's a cube root. 3ac squared d. ACD? Forgot the c. All right. First things first, I got to find the center. It's going to be x something squared plus y something squared equals, and over here goes the radius squared. So the first thing I do is find the center. 1, 2, 3, 4, 5, 6. So we went left 6, so we're going to put a plus 6 in here. 1, 2, 3, 4. We went positive 4, so we're going to put a minus 4 in there. So now the only thing I got to do now is find the length of a radius. Now, if I tried to pick this as my radius, you'd be guessing like 1, 2, 3.75. You can't guess, kids. You're not able to guess. You actually got to pick. So what we're going to do is we're going to pick this cool point right here. It's a point on the circle, and it's a cool point that I can find. Although I really drew it badly, if you draw it correctly, it's a point on the circle, and it's a point I can determine its coordinates of. And then what I'm going to do is, I could use the distance formula, but what I'm going to do is just use Pythagorean theorem. This is r, this is 3, and this is 2. So r squared is equal to 3 squared plus 4 squared. Or r squared is equal to 9, excuse me, it should be 2 squared, plus 4, or r squared is equal to 13. Well, I can stop there for this. 13 goes here, because don't forget, r squared goes on the right side. Now, if I want to know what r is, that's equal to the square root of 13. Now, in this case, I'm not putting plus or minus, because it's a length and you don't want a negative length. So my center is negative 6, 4. My radius is the square root of 13, and that cannot be simplified. And my equation I've already drawn. There's my equation right there. All right, there we go, kids. All said and done. Drive the analytic equation. Oh, focus directrix. Here we go. Let's do it easy. First of all, we have to pick our own point, x, comma, y. Now, easy is the distance between y, this point, and this line. Well, that's just y minus whatever that line is, 1 in this case. The more difficult part is using the distance formula to find the distance between the point and the point we picked. So we'll just do that right here. It is x minus 6 squared plus y minus 3 squared. And we're going to set those equal to each other. So y minus 1 is equal to the square root of x minus 6 squared plus y minus 3 squared. Now, to get rid of that square root, we're going to square both sides. So I'm going to square this side, and I'm going to square this side. Now, on the right side, that's just double distributing. So I get y squared minus 2y plus 1. On the right side, this thing and this thing just cancel each other out. So this is going to get double distributed, and this is going to get double distributed. So I end up with x squared minus 12x plus 36 plus y squared minus 6y plus 9. Let me clean all that up here. So I get y squared minus 2y plus 1 equals x squared minus 12x plus y squared minus 6y plus 45. Now the 45 comes from this 9 and this 36. All right. As usual, the y squareds are going to cancel because I'll bring that over. I'll add this 6y here, and I'll add it over here. So I get 4y equals x squared minus 12x. Now we're going to subtract this 1, and I get plus 44. I got one last step, and that's to get rid of this 4. 4, 4, and 4. So I get y equals 1/4 x squared minus 3x plus 11. That's all she wrote, chillin'. The annoyance level in force set class can be used. Oh, this shouldn't be force set class. This should be second. Oh, this is second set class. Oh my goodness, I can't believe I messed that up. Anyway, so here's my equation. My equation is A equals Latragna plus Cappiello times the square root of the number of questions s minus 5. So what I want to do is I want to solve. When I'm done, I want to have Q equals. So the first thing I'm going to do is bring this L over. So when I bring that over, it just changes sign. So it's A minus L equals C, square root of Q minus 5. Then I want to divide by C. So what I have now is A minus L over C equals the square root of Q minus 5. Well, how do I get rid of a square root? I square both sides. So what I have here then is A minus L squared over C squared equals Q minus 5. So if I just bring this 5 over and put it right here, I get this is equal to A minus L squared over C squared plus 5. All right. Part B says, Miss Latrogna's annoyance factor is 2 and Cappiello's is 4. And I want to know how many questions were asked. Oh, and the annoyance factor was a 10. So A was 10. Latrogna was a 2. Cappiello apparently was the worst day for her. That was a 4. We're going to type that stuff in. So Q equals the annoyance factor, which is 10, minus Latrogna, which was 2, squared, all over Cappiello, which is 4 squared, minus 5. Oh, plus 5. Plus 5. So this turns out to be 8 squared is 64 over 16 plus 5. 64 over 16 is 4, so this turns out to be 9 questions. And for some reason, I did not know this was a... Oh. So here we go. Simplify the weird thing. We get x squared plus 3x plus 15 is equal to negative 4x plus 3. So I've isolated the weird thing. Now to get rid of this square root, I'm going to square both sides. On the left side, it just goes away. It's x squared plus 3x plus 15 equals, this side I got to double distribute, negative 4x plus 3. So we're going to double distribute that. So we get 16x squared minus 12x plus 9. Now, this is my highest square root, so we're going to leave this here. This is positive. So we're going to leave everything there. So we're going to move everything to that side. So 0 is equal to 15x squared, because we're going to subtract this one, bring it over. Minus 15. Oh, wait, this is minus 24. That's minus 24. And I bring this 3x over. So that's minus 27x. And I subtract this 15. I get minus 6. Well, that's a quadratic that needs to be solved. I think what we'll do is take out the 3 first. So I end up with 5x squared minus 9x minus 2. Now we'll factor it. 5x, x. Obviously, this is minus 2 and plus 1, because that gives me my 9. So my two x answers are x equals negative 1/5, or my two answers are x equals negative 1/5, and x equals 2. Now, I told you before, on almost all these kinds of questions, you really need to check your answers. So that's what we're going to do over here. We'll store negative 1/5, negative 1 divided by 5, stow x. It'll fix it, make it pretty for me. And we're going to have to type in the left side and type in the right side, verify that they in fact equal each other. Go back to the original problem, square root of x squared plus 3x plus 15 plus 3x plus 15, now get out, plus 6x. And hit enter. 13 over 5. And the other side is 2x plus 3. 2x plus 3. 13 over 5. So that one works. Now, so this one works. So this one checks. Now we're going to try 2. So 2, control var x, enter. We'll go to this one first. 7. And then we'll go up here. $17. So apparently the 2 doesn't work. Like I stored 2 and I did 2x plus 3, and so 7 to 2 did not work. So just like almost always, especially with these big questions, one of them. Oh my God, you gotta be kidding me. Let's just do it this way. Doesn't work. So my answer, my final answer, let's see if I can get this, is -1/5. It is the only answer that works. That's it, kids. There she goes. All done. All right, bye. Oh, hit subscribe, hit like, hit the comments. Email me, donate. I could use a new computer. Clearly, my computer's having issues. Bye.